Hey everybody, welcome back to another episode of Calc Basics. In today's video we're going to discuss what an integral is and really give a conceptual understanding of this with trying to do as little math as possible. So let's begin by graphing a very simple function. Here we have our graph, and this function is just a straight line, and let's just say it's y equals 2. Is the function. So this would be 0 to right here. And say that we want to find the area underneath this function. So that is to say the area between the function and the x-axis. Well, it would be an infinite area if we just continued all the way out as far as the function stretched. But let's say we want to look at the area specifically from the point 0, 0 to 2, 0. So from x equals 0 to x equals 2. So we want this area right here. Well, there's a pretty simple way to do this. We can see that this is just a rectangle with a height of 2 and a width of 2. So this is just a rectangle. So the area is equal to 4. Well, that was pretty simple. So the area under this curve from x equals 0 to x equals 2 is equal to 4. The area under the curve y equals 2, that is to say. So let's make a little bit more complicated of an example. So number 2, we're going to draw another xy plane. This time our function is going to be a straight line with a negative slope like so. And let's say y equals, it's going to have to be negative x, say plus 2. So we'll say that this point up here is 0, 2. So that would make this point down here to 0, because the slope is just negative x. So it's negative 1 down for every 1 across. And we want to find the area bounded from 0, 0 to 2, 0. So the area under this curve from x equals 0 to x equals 2. And so we're going to shade that in like that. And once again, this is the area between the x-axis and the function itself. And as you can see, this time it's a triangle. So we have a triangle now. The area is equal to 1/2 times the base times the height. So in this case, the base is 2. The height is also 2. So it's 1/2 times 2 times 2, which is just 2. So far we've been able to use geometry to find these areas that we're looking for. But let's go one step further and bump our function up a degree. So we've dealt with a constant function, a linear function. Let's try, oops, that was really bad, but I kind of gave it away. Let's try quadratic now. It's a little better. So simple quadratic is this, y equals x squared. Y equals x squared. And so once again, this point right over here is be 2, 4. So this is x equals 2. And then this is y equals 4. Okay. And now we want to find the area under the curve from x equals 0 to x equals 2. So that's the area that I'm currently shading. So the area is not neatly contained into a geometric shape now. So we're kind of cooked. There's, using just geometry and our knowledge of different areas of different shapes, there's no way to find this area of the shaded region that we're looking for. So what do we do? Well, we're going to have to introduce a new operation to find this area. And this operation is the second major component or key operation in calculus. That is the operation of the integral, like so. And it's denoted by this symbol, and using this can allow us to calculate the area under a curve. To calculate the area under the curve of a function. So there we go. Thanks for watching, and we'll see you next time.